Good day everyone. This is my synthesis video about the reporter Hartzell Green discusses about the chapter 8 multiplexing. In his video, he discusses about the frequency division multiplexing, synchronous time division multiplexing, cable modems, asymmetric digital subscriber line, HDSL, and the multiple channel access. So later on, I will discuss to you what are those, its type and types based on the reporter that he discusses. So let's start. Typically, two communicating stations will not utilize the full capacity of the data link. For efficiency, it should be possible to share the capacity. The generic term for the sharing is what we call multiplexing. Multiplexing is the set of techniques that allows the simultaneous transmission of multiple signals across a single data link. It presents in the video the two types of multiplexing techniques. The first one is the frequency division multiplexing, or the FDM. And next is the time division multiplexing, known as synchronous TDM. The most heavily used and familiar for use that use radio or televisions, the frequency division multiplexing, and the TDM, or the time division multiplexing, is used for multiplexing digitalized voice streams and data streams. In the video, we then look at two schemes that combine both types of multiplexing, the cable modems and the digital subscriber lines. So we have a category of multiplexing. In the multiplexing, there is an analog and digital. In the analog, it under the FDM, like what we discussed earlier, and the WDM. And while in the digital, it under the TDM. In the video, it discusses the analog carrier system. The carrier in an analog carrier system is a signal generated by the system, and the carrier is modulated by a signal containing the information to be transmitted. And in the United States, they provide the long distance carrier system, and throughout the world is designed to transmit voice band signals over the high capacity transmission link. Example, the coaxial cable and the microwave systems. Next, we have the wavelength division multiplexing, or the WDM. It is a basically form of the frequency division multiplexing in the true potential of optical fiber. It is fully exploited when the multiple beams of light at a different frequencies are transmitted on the same fiber. It is a technology that increases the bandwidth by allowing different data streams at different frequencies to be sent over a single optical fiber network. Independent signal at WDM is present. Next, that discusses the reporter is the TDM link control. It is the digital multiplexing technique. It is a method of transmitting and receiving independent signals over a common signal path by means of synchronized switches at each end of the transmission line, so that each signal appears on the line only a fraction of the time in an alternating pattern. And the framing is that has no flag or sync characters bracketing TDM frames. It is identifiable bit pattern used as control channel. Then adding digit frame is most common here. Receivers compare incoming bits of frame position to the expected pattern, and etc. Next, the reporter tackles about the pulse stuffing. It is the most common solution of the problem of synchronizing various data sources. The stuff pulses inserted at fixed locations in frame and removed at the multiplexer. And also, it shows the SONET SDH, or what we call the synchronous optical network, that is an optical transmission interface originally proposed by Mr. Belcour and standardized by ANSI or the American National Standardized Institute. The Sonnet has the high-speed capability of optical fiber. Next one is the cable modems. Is the device that allows a user to access the internet and the other online services through a cable television network. The downstream that cable schedule delivers data in small packets, and the upstream that the user requests time slot on a shared upstream channel. And the cable spectrum division that support both cable television programming and data channels. It has three ranges: the user network data, the first one, and the second one is the television delivery, the downstream, and the last network to user data, it also downstream. Next is it the ADSL or the asymmetrical digital subscriber line. It is linked between subscriber and network, uses currently installed twisted pair cable and has a range of up to 5.5 kilometers. The DMT multitune, the multiple carrier signal at different frequencies and test the user subchannels, sending some of bits each channel. Then the next is the SGLC. It was developed in the late 1980s by Mr. Belcour that provides a more cost-efficient means of delivering a T1 data rate. It uses the 2B1Q coding scheme that discussed by the reporter to provide a data rate up to 2 Mbps. And last is the FDMS or the frequency division multiple access. It is a technique used to share the spectrum among the multiple stations. Lastly, the TDMA or the time division multiple access. There is a single relatively large up frequency band that is used to transmit a sequence of the time slot. And that's all for my synthesis video. Thank you. Have a good day.